Okay, this is chapter 21.3 and 21.4. We're combining them because they both talk about the area of a triangle. Okay, and today's learning goal is to find the formula. You guys are all going to come up with how to find the formula of a triangle using what you already know. And what you already know is how to find the formula for the area of a parallelogram. Okay, so let's review. Okay, so let's draw a parallelogram. You have graph paper, I have graph paper. Let's draw the same parallelogram though. Fine, let's make our base, let's make it 6. So go ahead, oh, that's not gonna work. Go ahead and draw 6 squares across the bottom. And mine might not be exact because my squares are very small. So 6 squares, and then I want you to count up, let's make the height, okay, let's make it 5. And then you're going to shift over 3 squares, and you're going to draw a parallelogram like this, right? Okay. So draw a parallelogram on your graph paper and label the base and the height. So the base we said was 6. It's hard to see in that color, so let's do black. Let's just call these centimeters, okay? So our base is 6 centimeters. And how do we find the height again? How do we find the height again, Chris?
We took the parallelogram.
What is height? We know that base is any length, so we usually pick the bottom. But what's the height? Aditya?
Oh, 5.
What is the height? How do I know where to draw and label my height? So to draw my height, I start at the vertex, which is the corner, and I draw a straight line perpendicular, until it touches the base. And in this case, how many boxes is your, oh, that's not perpendicular. How high is the height of your parallelogram right now? If each box is 1 centimeter, how many centimeters is the height? 5 centimeters. Let's label it. Okay, and what do we know about the area of a parallelogram? How do we find the area of a parallelogram? Erica? You multiply the base, which is 6 centimeters, times the height, which is 5 centimeters, and so the area of our parallelogram is?
30 centimeters squared.
30 square centimeters. Good. Very good. Make sure you write this down. Okay, so now we have the same parallelogram. Our base is still 6 centimeters. Give me 1 second. And then our height is still 5 centimeters, right? Now, here's what I want you to do now, though. Okay, I know this is kind of hard to read. Okay, our base is still 6 centimeters and our height is still 5 centimeters. I want you to draw a line from this vertex down here to the opposite vertex here. Draw a straight line connecting those 2 vertexes. And I want you to color in lightly with your pencil that bottom half of it. By drawing that line connecting the 2 vertexes, what shape did you make?
2 triangles.
Now you have 2 triangles. Are those triangles the same size?
Yeah. Yes. Yeah.
So if I cut one of them away, would I be cutting this shape in half?
Yeah.
So if I'm cutting the shape in half, what am I doing to the area?
Cutting it in half.
I'm cutting it by how much? Is the area of one triangle bigger or smaller than the area of the whole parallelogram? Smaller by how much?
Half.
That triangle is exactly half of that parallelogram, isn't it?
Yeah.
Okay, now let's take a look. What is the base? We're just going to look at this one blue triangle. How long is the base of this triangle?
6 centimeters.
6 centimeters. How tall? Sometimes you guys have seen sometimes the height needs to be drawn outside, right?
Yeah.
How tall is the height of the triangle?
5 centimeters.
5 centimeters. So are the base and the height of this triangle the same as the base and the height of the parallelogram? So how can I use what I know about the area of a parallelogram to find the area of a triangle? How can I use what I know? So I know that, let's do this. The base of the parallelogram, let's talk about the parallelogram. Parallelogram. Pretend I can fit that there. What was the base? 6 centimeters. What's the height?
5 centimeters.
Okay. Now let's talk about what we know. The parallelogram, the whole black parallelogram, and the one blue triangle have the same base and the same height. Yes?
Yeah.
Do they have the same area?
No.
Which one's area is bigger? Sakshi? The parallelogram. Which area is smaller? Hemant? The triangle's area is smaller than the area of the parallelogram, but they have the same base and the same height. How much smaller is it by? Ruba? By half. Okay, so here's my question to you then. How can we use what we know about the area of a parallelogram to find the formula for the area of a triangle? Look at your pictures and decide what's the difference between the area of a parallelogram and the area of a triangle, even though they have the same base and the same height. Okay, so here we have a parallelogram, and the base is 10, and the height is 5. We also have a triangle right next to it. Okay, and this triangle, the base is 10, and the height from the vertex perpendicular down to the base is 5. Help me please find the area of the parallelogram first. Okay, so how are we going to find the area of the parallelogram? We know that the formula for parallelogram is what, Nadia? How do I find the area of a parallelogram? The base is 10 and the height is 5. How do I find the area? Yeah, I multiply the base times the height, which is 10 times 5, which is 50. Let's call them inches squared. Okay? Now let's talk about the triangle. My triangle's base is 10 inches. Bless you. My triangle's height is 5 inches. Am I also going to do 10 times 5 equals 50 inches squared?
No.
Should the area of this triangle be bigger or smaller than this parallelogram?
Smaller.
Smaller by how much?
Half.
So how can I find the area of this triangle? Kevin.
You do 5 times 10,
Okay,
and then divide that by in half, and then you split that in half.
good. So 5 times 10, all of that, I would divide it by 2. Because we know that the area of a triangle is half the size of the area of the parallelogram. Yes? So what's 50 divided by 2? 25 inches squared. So what do we know then is the formula for the area of a triangle? The area of a triangle is equal to half of the base times the height. Yes? If this was my notebook, I would do something fancy like this so that I could see forever and ever that the area of a triangle is half of the base times the height.